In this lecture, I will be discussing the raw data format of DC sweep over two variables, including voltage source and temperature. In the last lecture, we studied the data format of DC sweep over a voltage source and how to import the data into Python IDE. Today, I will show you how to DC sweep over two sources at the same time, both voltage and temperature. Go to the folder of this lecture, open the given schematic in LTspice. This is an example of DC sweep over voltage source V1 and temperature temp. Right-click over the DC syntax. You can see the DC sweep is chosen. The first source is V1. It's a linear sweep starting from 0 to 2.5 volt with increment as 0.1 volt. We go to the second source. Temp means the temperature. The type of sweep is least. The first value is 25 degrees C. The second value is 125 degrees C. And hit OK. Now let's run the simulation. The plot window pops up. We move the mouse over D1 to check the current. Again, the x-axis is the voltage over V1, changing from 0 to 2.5 volt. There are two traces are shown at different temperature steps. The first one is 25 degrees C. The second one is 125 degrees C. But how do you know which one is which? You move your mouse over the plot window, right-click, go to View, Step Legend. Now you can tell the green one is at temperature at 25 degrees C. The blue one is 125 degrees C. We have finished the LTspice simulation, and the raw data will be created in the same directory. Now let's close LTspice. Let's first open the raw data in Notepad. The plot name is DC transfer characteristic. Flags are real, forward. That means the voltage or temperature is changing from low to high. Stamped means with DC sweep over multiple sources. Number of variables is 4. Offset 0 command is the same, and the variables are listed here. Binary data will be discussed later. Now let's open the log file in Notepad. As shown here, there are two steps over temperature. The first one is temperature equals to 25. The second one is step over temperature equals to 125. Now let me give you a detailed discussion over data format. Because we DC sweep over multiple variables, the data structure looks like nested for loop. For the outer loop, we changing the source 2, and starting from the source 2 value 1, the stop value is value m. For inner loop, we have source 1, starting from source 1 value 1. The stop value is source 1 value n, and we keep changing source 1 in the inner loop. And in the inner loop, we run the DC sweep at the given source 1 and source 2. This is how LTspice run for a nested DC sweep. The raw data format remains the same for a DC sweep at each step. Source value is 8 byte. The operating point of each variable is 4 byte. For a step of source 2 value 1, we can see this is the data structure. Source 1 value 1 8 byte, followed by variables in 4 byte. Value 2 of source 1 in 8 byte and followed by different variables in 4 byte, and so on and so forth. After this step is going to be the step of source 2 value 2 and so on and so forth. So that's all for the data structure. Let's move on to Python and show you a quick demo. Before the demo, let's close the log file. We go to Spider. Make sure you are in the same directory as the folder. As we did before, first we import LTspice 3. We use LTspice 3.sim data to retrieve the data as the variable SD, and input is the raw data name. SD.variables give you the name of all variables, and SD.values that's the DC operating point from raw data. We save as this name, DC_OP, _temp, _sweep. Particularly, you can get the step variables as save as step_var. The last one is SD.step_values, give you the values of the step variable. In this case, that will be the temperature. Let's remove all variables and run the code. So the step values and the step variables are shown here. Step variable is temperature, values is 25 degrees C and 125 degrees C. So the name of 4 variables are shown here: V1, voltage of node 1, current of D1, current of V1. This is the final data for DC sweep. This is a nested list. You can see at the first level we have a list of 4 elements, and each element is still a type of list with size equals to 2. If you double click, these are 2 NumPy arrays. Each one is corresponding to a particular temperature step. This one is voltage over node 1. This one is for the current of D1. The last one is current over voltage V1. This concludes the demo of importing raw data into Python IDE. Here is the reference for this lecture. Thank you very much. See you next time.